What's up guys, this is Masi. Welcome to another video. In this video I want to continue solving some questions regarding projectile motion. So the question I have here is, you throw a ball toward the wall and at a speed of 25 meters per second and at angle 40 degrees above the horizontal. The wall is distance d equals to 22 meters from the release point of the ball. How far above the release point does the ball hit the wall? And what are the horizontal and vertical components of the velocity when it hits the wall? So it's pretty much like something like this. You throw the ball, that's 40 degrees, velocity is 25, and here is the distance, which is 22 meters. So first of all, let's find out the time, total time. Total time is gonna say, it's gonna be Vx, which is the horizontal velocity, times distance equals to distance divided by total time, or we can say distance equals to Vx times time. So we have the Vx, we have d, so we can find time. So we can say time equals to d over Vx. D is 22 meters and Vx is gonna be V times cosine theta, so 25 times cosine 40 degrees. 1.15 seconds. That's how long it takes. So now we need to find out the vertical distance, how far it goes. So we know the formula is y minus y naught equals to y naught y t minus 1 over 2 gt squared. So y minus y naught is going to be pretty much delta y, the change in y. Vy naught is initial velocity times sine theta times t minus 1 over 2 gt squared. Now let's sub the numbers. This one is 25 sine 40, t is 1.15 minus 1 over 2, 9.8 times 1.15 to the power of 2. So it is 25 times sine 14 times 1.15 minus 0.5 times 9.8 times 1.15 squared. That's going to be approximately equals to 12 meters. And in next part, we need to find out the horizontal and vertical components of its velocity. So Vx equals to V dot sine 40 cosine 40, and Vy is going to be V naught sine theta naught minus gt. That's how we find the horizontal and vertical component of velocity in the end. Vx is not changing at all during the release, so we have 25 times cosine 40, that's going to give you around 19.2 meters per second. And here you have V naught, 25 sine 40 minus 9.8 times 1.15. It's going to give me 4.8 meters per second. So these are the horizontal and vertical components of velocity. So next question is saying, a plane driving with constant speed at an angle of 53 degrees with the vertical releases a projectile at an altitude of 730 meters. The projectile hits the ground 5 seconds after release. We need to find out the speed of plane, How far does the projectile travel horizontally during its flight? What are the horizontal and vertical components of its velocity just before striking the ground? So the first thing we need to do is going to be pretty much like that. Something like that. And this angle is going to be, since this one is 53, this one is going to be 90 minus 53, which is going to be negative 37 degrees. So we have y minus y naught equals to v dot y times t minus 1 over 2 gt squared, which is going to be y minus y naught v dot sine theta naught times t minus 1 over 2 gt squared. So final height is going to be 0, obviously, and the initial one, as it says, is 730. V is velocity. Do we have that? No, we don't have it. Just v naught sine negative 37 times 5, which is the time, minus 1 over 2 times 9.8 times 5 squared. So we need to find out the velocity when we have it. It's going to be, when we rearrange it, we got 202 meters per second. Now we need to find out, it says, how far does the projectile traverse horizontally? So we know d equals to vx times t, horizontal distance. So it's going to be v dot times cosine theta dot times time, which will be 202 times cosine negative 37 times 5 seconds, which will be 806 meters. Now after that, we need to find out the x component of velocity and y component of velocity, horizontal and vertical. Vx is v naught cosine theta naught, which is 202 times cosine negative 37. That will be 161 meters per second. And the vertical component is going to be vy equals to vy naught, which is v naught sine theta naught minus gt. So we have 202 times sine negative 37 minus 9.8 times 5, which will be negative 171 meters per second. Next question is saying that a rifle that shoots bullets at 460 meters per second is to be aimed at the target 45.7 meters away. If the center of the target is level with the rifle, how high above the target must the rifle barrel be pointed so that the bullet hits dead center? So it's going to be pretty much something like that. It goes up a little bit and goes down, and here we have theta. So the initial and final y is going to be the same, so we can say that d, which is the distance, that's 45.7 meters, equals to vx naught times t, and y minus y naught equals to vy naught t minus 1 over 2 gt squared. So let's sub it there. D is 45.7 meters. Vx is gonna be v naught cosine theta naught times time, and y minus y naught is different, is going to be 0 because the initial height and final height is going to be the same. So we can say that's going to be v naught sine theta naught t minus 1 over 2 gt squared. So from the first equation, I'm going to say t equals to d divided by v naught cosine theta naught. Then we can sub it in here. So it's going to be v naught sine theta naught d divided by v naught cosine theta naught minus 1 over 2 g d over v naught cosine theta naught to the power of 2. Then we can say that's going to be, these two cancel out, and we have d times sine theta naught divided by cosine theta naught equals to 1 over 2 g d squared over v naught squared cosine squared theta naught. Then this cosine cancel out with the exponent here. When you cross multiply it, it's going to be d times sine theta naught times 2 times v squared cosine theta. It's going to be equal to gd squared. Then this exponent with d is going to cancel out, and at the end we have 2 sine theta naught cosine theta naught times v naught squared equals to gd. And we know 2 times sine theta cosine theta is going to be sine 2 theta. So we have sine 2 theta naught times v naught squared equals to gd. Now in order to find the theta, we can say sine 2 theta equals to gd over v naught squared, which is going to be 9.8 times 45.7 divided by 460 to the power of 2. That will give me 2.11 times 10 to the power of negative 3, and then we can find out the theta by finding the inverse of sine. That will be 0.06 approximately. So that's going to be the angle. So the rifle has to basically aim something like this. Theta, this is D, and L. We need to find out L above the center of the target. So we can say tan is opposite divided by adjacent. So L will be D times tan theta. D is 45.7. Tan theta is going to be tan of 0.06. The answer is going to be around 0.047, or if you round it, it's going to be 8 meters, or when you convert it to centimeter, it's going to be 4.8 centimeter. Next question is saying that a ball is shot from the ground into the air at a height of 9.1 meters. Its velocity is v equals to 7.6 I plus 6.1 j meters per second. To what maximum height, or what is the maximum height does the ball rise, and what are the magnitude and angle below the horizontal of the ball's velocity just before it hits the ground, and find out how far does the ball freely fall during the first half. So now it says at the height of 9.1 meters we have this velocity. So we can say, let's say v1y squared equals to v naught y squared minus 2 times g times delta y. So this one we have it, which is the y component, is 6.1 squared equals to initial velocity, which we don't have it, minus 2 times 9.8 times 9.1. When we solve it, we're gonna find out v naught y equals to 14.7 meters per second. Then, in order to find maximum height, we need to have this equation again. I'm gonna call it v2 this time. v2y squared equals to v naught y squared minus 2 times g times maximum height. I'm gonna show it with h. So now we have v2y is definitely going to be 0 at maximum. v naught we have 14.7 to the power of 2 minus 2 times 9.8 times h. So when you rearrange it, you're going to get 14.7 squared divided by 2. That's going to be around 11 meters. And after that, we need to find out the horizontal distance. We're going to say zero v naught y t minus 1 over 2 gt squared, and on the other hand we have r equals to v naught x times t. These are the y and x component. Again, instead of t here, I can sub r over v naught x. So when you rearrange it, you're gonna get r equals to 2 v naught x times v naught y divided by g, which will be 2 times the v naught x, since it's not changing, it's the same as 7.6, so it's going to be 7.6. v naught y, we have it, this 14.7 divided by g, which is 9.8. That will be 22.8 meters. And finally it says, what are the magnitude and angle of the ball's velocity just before it hits the ground? So in this case, we can say the final velocity, I'm going to call it Vf, is the same as Vx, which is 7.6 meters per second. V, that's Vfx. Vfy is going to be negative 14.7 meters per second. So, because the final, since it starts from the ground and it's returning to the ground, the final velocity in y direction has to be the same as initial velocity in y direction. So that's why it's negative 14.7. So Vf will be square root of 7.6 to the power of 2 plus 14.7 to the power of 2. That will be square root is going to be 16.55 meters per second. That's going to be the final velocity. If you want to find out the angle, it's going to be tan inverse negative 14.7 divided by 7.6. That make it as tan inverse. It's gonna make it around negative 63 degrees, or we can say it's gonna be 117, because 180 minus 63 is gonna be 170. A ball is thrown up on a roof, landing 4 seconds later at a height of h equals to 20 meters above the release level. The ball's path just before landing is angled at theta equals to 60 degrees, as you see here with the roof. Find the horizontal distance d it travels, and what are the magnitude and angle of the ball's initial velocity. So we need to use a trick here. The trick here for this example is going to be we're going to use time reverse problem. It means that we just consider it, the ball is thrown from here and it lands here backward. So we can say y naught is 20 meters and final y is going to be 0. Time is 4 seconds. So we can say y minus y naught v naught y t minus 1 over 2 g t squared. Then we have 0 minus 20 vy naught times 4 minus 1 over 2 9.8 4 squared. We need to find out v naught y. V naught y is going to be v naught times sine this angle here, which it says 60 degrees. So that will be, that will help us to find out y naught. For finding v naught y, we need to use this example here. We need to rearrange it. So that's going to be negative 20 v naught y times t. If you have negative 78.4, so that makes it positive 58.4 equals to v naught y times 4. So v naught y is going to be 58.4 divided by 4, which is 14.6 meters per second. And now we sub it here with 14.6 v naught times sine 60, which is 0.866. So v naught will be 14.6 is going to be 16.9 approximately meters per second. Now based on that we can find d. D is v naught x times t, which is going to be v naught cosine theta times t, which will be 16.9 times cosine 60 times time, which is 4 seconds. It's going to be 33.8 meters. So now that's the horizontal distance. We need to find out the final velocity in y and x direction. Vx pretty much is going to be the same because it's not changing. We found it somewhere. Did we found it? Yeah, you had it here. 16.9 times cosine 60. That's going to be 8.45 meters per second. And Vy is going to be v naught times sine 60. And it's going to be downward, so it's negative. So we found it somewhere here. 14.6. That's going to change. This was the initial one. For the final one, we need to have, that's the initial. For final one, we need to have Vy equals to Vy naught minus gt. So it's going to be Vy equals to 14.6 minus 9.8 times 4. That's going to be 14.6 minus 9.8 times 4. That will be negative 24.6 meters per second. So that's the final velocity in y direction. So total velocity is going to be Vx squared plus Vy squared. So that will be 8.445 squared plus negative 24.6 squared. And when you find the square root of it, that will give you 26 meters per second. If you want to find out the angle is going to be tan inverse Vy over Vx. Vy is negative 24.6. Vx is 8.45. And it's going to be negative 2.911. It's going to give you negative 71 degrees. So that's the final answer. I hope you enjoyed this video. And if you found it useful, please like this video and don't forget to subscribe this channel. Thank you so much for watching and have a great day.